Welcome back to Concepts in Arithmetic. We are going to continue working on the algorithms for the arithmetic operations. If you look through our previous videos on this playlist, you'll see the addition algorithm, subtraction, and multiplication. So that just leaves us with division. So the next couple of videos are going to be about the long division process. So let's switch over to the document camera here. Change up the scene. Okay, so the long division process is important because it's useful for understanding fractions and decimals, and later on in the student's education those will be compared to the irrational numbers. And this is something we're going to emphasize here in this video. The long division algorithm emphasizes the idea of successively better approximations, and we'll understand as we look at the examples how each stage in the long division process gives you a better approximation than you had in the previous stage. Okay, so as far as the prerequisites for getting students into the division algorithm, they need to really understand how place value works. Okay, and all the stuff that we've done up to this point has had a place value emphasis. And of course, they need to know their one-digit multiplication facts. So the three stages for teaching the division algorithm involve beginning with one-digit divisors, which is what we're going to do in this video. Maybe have something on estimation, because that's very important when you get to two-digit divisors, as we'll see later on. Okay, so let's go ahead and look at some one-digit divisor examples. Okay, so this is a basic one here, a warm-up example, if you will. Okay, so we have 20 candies to be shared equally among 3 children. Okay, now if you remember something that we called the division algorithm before, that's a little different than the long division. Okay, we would do something like 20 divided by 3 equals, oh gosh, what is it, 6, remainder 2. Or another way to write that would be 20 equals 6 times 3 plus 2, where 6 is the quotient and 2 is the remainder. Okay, so the reason I said this is a warm-up example is you really only need, you don't really need long division to do this, but you can introduce the setup to long division here. So our divisor is 3, so that goes on the outside. We have 20. Okay, the dividend, the thing being divided into, is 20, that goes over here. So we put the quotient up here. 6 times 3 is 18, with a remainder of 2. Okay, so we can illustrate how the long division algorithm works. Putting our quotient up top, this is what we would get. We'd distribute 18 of the candies out to the kids, and there would be 2 left over. So there's 3 numbers that we're keeping track of. So each child gets blank candies for a total of blank distributed with blank left over. Okay, so I'm in the way there. Okay, so each child gets 6 candies for a total of 18 distributed with 2 left over. Okay, so we got 20 candies. We can't distribute those evenly among the 3 people. We can distribute 18 of the candies evenly, giving each child 6 candies. And 6 left over. Okay, so a problem like this would be good for introducing this new setup, the long division setup, because we would probably start with this division algorithm type of setup. Okay, let's look at another example, maybe a little more involved here. So, split $5.22 equally among 3 people. Oh, and I should also note that in the previous example and in this example, we were using the partitive approach to division, okay? In each case, we're dividing our quantity into 3 parts. We don't know how big the parts are, hence partitive approach. Okay, so let's go over the long division process here. So $5.22. Okay, these are the dollars, this is the cents. Okay, so first thing you do, distribute your dollars. Okay, you have $5 to go around, 3 people. Okay, so each person gets $1. That means you have distributed $3. So you have $2 left over and 22 cents. So now you're focusing on distributing $2.22. Okay, so what you do is you change the $2 to dimes. Okay, make it 20 dimes. Plus this down here, you've got, I mean, this is everything you've got left, right? But distribute the dollars. Anything that's left over, convert it to the next unit down. So we said we had 22 dimes. Okay, 22 dimes. Okay, I can distribute 7 dimes to each person. That means I've distributed 21 of the 22 dimes. So that leaves me with 12 cents. So distribute dollars. Distribute the dimes. And lastly, distribute those pennies. Okay, so we started out with the $5.22. Each person got $1. That leaves us with $2.22 left to distribute. We convert the $2 to 22 dimes. We distribute those. Each person can get 7. That means we've distributed $2.10 worth of dimes, which leaves us with 12 cents. Now, of course, you have to change that dime for 10 pennies. So now you've got 12 pennies, and of course that means each person can get 4 pennies, and now we've distributed everything equally. Okay, so let's look at kind of the stages here. So we've got our $5.22. Okay, so each person's going to get $1. And then when we go to the dimes stage, we saw that each person would get 7 dimes. So after the stage of distributing dollars, each of the people has $1. After the dimes distribution stage, each of the people has $1.70. And then finally we're down to distributing those pennies. So now each person has $1.74. So if you look back, earlier in the video I mentioned that we're doing successive approximations at each stage. Okay, so in the first stage of this, we know how many dollars each of the people gets. In the second stage, not only do we have the dollars that they get, we know the dimes. And in the last stage, we finally figure out how many pennies they get, and that completes the whole process. Okay, let's look at one more example. In this example, we'll do a measurement approach. And here's what I want to do. I want to do 8 divided into 2,147. Okay. So let me leave myself a little space here to work underneath. But now, if you remember the measurement approach to division, okay, I'm starting at 0, and I'm imagining that I have an 8-inch ruler. So I'm starting at 0, and I want to get to 2,147 using my 8-inch ruler. And the question I'm trying to answer is, how many times do I have to use that ruler to get here? All right. Well, if I count by 8s, this is going to take forever. Okay, so what we're going to do is we're going to take big jumps at the beginning. We're not going to count by 8, we're going to count by 800. Okay, so if we're counting by jumps of 800, first one gets us to 800, next one gets us to 1600. Now, if we were to take another jump of 800, we would overshoot, and we'd get to 2400, so we don't want that. Okay, so we can take 2 jumps of 800, so we're going to keep track of that right here. We took 2 jumps of 800, which took us to 1600, and then we'll subtract. Okay, and let me see here, 547 is the difference there. So that's what this is right here. We have 547 left to go. So now we imagine zooming in right there on that. We're not starting at 0 anymore. We're starting at 1600. And we're trying to get to 2147. Now, of course, we're not doing jumps of 800 anymore. We just said if you did any more jumps of 800, you'd go over 2147, which is not what we want. What we're going to do now is jumps of 80. Okay? How many jumps of 80 can I get in? Okay, so let me think here. If I do one jump of 80, I'd have 1680. Another one. Okay, another jump of 80. 1760. 1820. 1900. 1960. Let me see, can I fit in another one? Let me see, if I do another one, that would be 2020, is that right? No, 2040. Let me make sure I'm counting right here. So 80, 160. No, okay, this step isn't right. Sorry about that. That's why we have erasers here. 1760, this would be 1840. Okay, add 80 to this. So you'd have, oh, 1920 was right there. Okay, so I should get 1, 2, 3, 4, 5, 6. I'm seeing I should get 6. Okay, so 6 times, so looks like I can get to 2040 right there. So 80, 160, 240, 320, 40, 480, 2080. Okay. 320, so that'd be 1920. This would be 2,000. Okay, so jumps of 80. If I take 1, 2, 3, 4, 5, 6 jumps of 80, I'll get to 280. Now, really, what we might also think about, we just want to make up that gap. Okay, you don't really have to go from 1600 to 2147. The gap from the first stage was 547, and you're counting in jumps of 80. So you got 80, 160, 240, 320, 400, 480. Oh, I guess we could get another one in there, couldn't we? Oh no! If I do another jump of 80, that'd be 560. So that'd be too much. So 1, 2, 3, 4, 5, 6 jumps of 80. So now we record that right here. That's the jumps of 80. So the closest we could get was 480. And now we subtract that. Okay, and when we do this subtraction, we are going to have to do a little unbundling here. So it looks like we have 67. Okay, now this last gap, that's what that is. That's that last gap, 67. Okay, so now finally we think of jumps of 8. We're going from 0 to 67 jumps of 8. So we have 8, 16, 24, 32, 40, 48, 56, 64. Okay, I can get as close as 64 by taking 1, 2, 3, 4, 5, 6, 7, 8 jumps. So 8 jumps, 64. So there's 3 left over. Okay, so up here is my quotient of 268 with a remainder of 3. Okay, now at each of these stages, we had as close as we could get doing jumps of 800. Okay, so that's 2 jumps of 800. So that's 200 added to my quotient. Next stage we had 260, and then 268, and that's the closest that we can get without going over. 268, remainder 3. Okay, so if you're thinking measurement division, remember the measurement approach to division was, imagine you have a ruler of a certain specified size, and you're asking how many copies of that ruler can I use to measure my segment? Well, don't think of doing it individually. Take bigger jumps. You're dividing by 8, don't take jumps of 8 the whole time. Start with jumps of 800 if you can. We could have started with jumps of 8,000, but that wouldn't work here because your first jump takes you past this target. Remember, you want to get as close as you can to the target without going over. So we can't use 8,000, let's use 800. We can do 2 jumps of 800. And then we focus on the gap. The gap was 547. And now we're going down jumps of 80. 1, 2, 3, 4, 5, 6 jumps of 80. Gets us to 480. That's as close as we can get to 547. And then we had 8 jumps of 8, getting as close as we can to the remaining gap of 67.